This is the second block of Topic 12. In this lesson, we're going to be able to connect similarities to transformations, more specifically dilations, and we'll also investigate how the different scale factors affect the transformations, which again is dilations, what we're looking at. So from lesson 12.1, this is actually number 6 on last night's assignment. These are the answer choices that you're given, but what I want you to make sure that you understand is that you look at specifically how they wrote those ratios in parts C and D, answers C and D. I want you to notice how the ratios are set up. Notice that the numerators of those fractions are all the image links. They have the prime notation on them, and the denominator are the original links, and the same in part D. This is really important to understand because when you write a scale factor, you will always put the image length on top of the pre-image or the original length. Always the image on top. All right, in this animation that we're going to start off looking, we're going to explore some different dilations on a triangle RST coming from a point J. So point J is called the point of dilations. We're going to manipulate the scale factor and see how that affects our image. So as we're going through this, you should be able to answer questions 1 through 6 on your notes. So here's point J. It is our point of dilation, and here's our original or pre-image triangle RST. I know that because of the prime notation on the other triangle. That tells me that is the image. So as we are set up right now, we are looking at a scale factor of 2. So a lot of times students think that means that the triangle is twice as big as the original one. And I want us to be careful about thinking that way because sometimes what we think we're talking about in size is its area, and that does not mean necessarily that this triangle has twice the area that the original one does. What does double in length is the side lengths of each one of the sides. So for instance, if side ST was 1 centimeter long, then S prime T prime would be 2 centimeters long. It is twice as long. The other thing that the scale factor affects is how far these points are from our point of dilation. So for example, if point S is 3 centimeters away from point J, then S prime would be 6 centimeters away from point J. Because of the scale factor being 2. It's twice as far away from the point of dilation. So I'm going to show a couple of calculations here. Here it shows the ratios of the side, and it's just showing us that each of the image sides compared to the original or pre-image side has a ratio of 2, just like our scale factor. If I look at the angle measures, the important thing to notice is that when we dilate a figure, the angle measures are not changing. So for example, angle SRT, vertex R down here, has a measure of 23.96 degrees. Well, S prime R prime T prime with the vertex R prime also has an angle degrees of 23.96. So your angle measures do not change when you dilate a figure. It's just the side lengths that are changing size and how far away you're getting from your point of dilation. So if I increase the scale factor from here, those are the things that we should notice are going to change. My triangle is going to get farther away from point J, and notice that the ratio of the sides is increasing as well to match the scale factor. But again, did my angle measures change at all? No, they did not. What would you expect would happen if I move my scale factor towards 1? As I get closer to 1, notice the triangle's getting closer and closer to the original one, closer and closer to point J. My ratio of the sides is always going to match my scale factor. And again, notice it's the image length on top of the pre-image length when we look at that scale factor. Now, what do you think is going to happen when I go to a scale factor of 1? I hope that you can see the closer I get there, the closer it gets to the original triangle. And as soon as I make my scale factor 1, they are exactly the same. They're in the same position, they're the same size. The scale factor of 1 creates a congruent figure. If you have a scale factor that is not 1, they're not congruent. Those figures are now similar because they have proportional sides, but they are not congruent because the side lengths are not congruent. Now, once I go below 1, of a scale factor of 1, now when I go greater than 1, I'm increasing the size of the figure. But as soon as I go less than 1, notice the size of the image is actually smaller than the original, smaller than the pre-image. And it's getting closer to point J. So as I have a scale factor between 0 and 1, those create reductions of the figure itself. They get smaller. So greater than 1 makes an enlargement of the original figure, but going between 0 and 1 makes a reduction, a smaller figure. And again, it's closer to point J. Again, the ratios are always image over pre-image and should match your scale factor. And my angle measures are not changing. Now, as I get closer to 0, I'm getting closer and closer and closer to that point of dilation. What do you think will happen when I get to a scale factor of 0? I hope you see that these points are getting closer and closer to each other and closer to J. And when I actually make a scale factor of 0, they are all 1 point. They are the center of dilation itself. So a scale factor of 0 takes all of these vertices of that pre-image and makes them the point that is the center of dilation, a single point. Now, positive scale factors we have been looking at. What happens when we look at a negative scale factor? Well, when I go on the other side of 0 and create a negative scale factor, an interesting thing happens. So I want you to look at what happened to those points. Notice the image over the pre-image is still my scale factor, but it's positive because these distances are what these are representing, and distances cannot be 0. So even though my scale factor is negative, the ratio of the sides is always going to be positive because those side lengths are not going to be negative lengths. The length of R prime S prime is not negative. So when we compare its side length to RS, we get a positive value here. Also, the distance from J is not negative, right? But the scale factor is negative. So notice point R was at the bottom of triangle RST, and when we have a negative scale factor, it ends up at the top. T was on the right side, and ended up on the left side. S was at the top, and S prime ended up at the bottom. So when we get a scale factor of -1, we still create two triangles that are congruent to each other because they have that ratio of the sides that is 1. But this is not just a translation here. What happened to that figure? The R moved to the top, the S moved to the bottom, the T moved to the other side. I hope you see that that's a rotation. If you look at R prime J and R, they are in a straight angle together. And how many degrees does a straight angle have? 180, right? So this is a 180 degree rotation around point J. You'll see S, J, and S prime are in a line together. T, J, and T prime are in a line together. So when you go to a negative scale factor, you're not just reducing or enlarging the figure, you're also doing a 180 degree rotation of it around that center of dilation. So when I go to a scale factor of -1.5, this image is bigger than the pre-image, it's farther away from J, and it's also a 180 degree rotation from the original. So let's make sure that we answered questions 1 through 6 in your notes correctly. So number 1 on your note says, as the scale factor changes, what do you notice about the measures of the corresponding angles? Underline angles. I hope you recognize that the angles were not changing measures. The corresponding angles are always congruent. The corresponding angles are congruent. Number 2 says, what do you notice about the ratios of the lengths of the corresponding sides? So now we're talking about the sides. The corresponding sides, that ratio was always constant. All that means is that every single one of the ratios were the same. So when we looked at the ratio of R prime S prime to RS, it was the same as S prime T prime to ST. All those comparisons of the sides, the corresponding sides, were the same number. And that number, remember, is called your scale factor. So on number 3, it says, how is the ratio of the lengths of the corresponding sides related to your scale factor when the scale factor is positive? And that means they are the same. The scale factor and that constant ratio are the same number. The constant ratio we talked about in number 2 is your scale factor. And remember, it's important to note that when you write the scale factor, you always put the image length in the numerator over the pre-image in the denominator. Number 4 says, when the scale factor approaches 0, at what point does the image triangle, triangle R prime, S prime, T prime, become a reduction of triangle RST instead of an enlargement? Well, it becomes a reduction when your scale factor is between the numbers of 0 and 1. So when your scale factor is between 0 and 1. If it's greater than 1, it's an enlargement. But if it's between 0 and 1, it's called a reduction. It makes it smaller. What happens when the scale factor is negative? So remember, when that happened, the figure was actually rotated 180 degrees and also dilated as well. So in addition to the dilation, we have a rotation of 180 degrees. Number 6, can a scale factor of 1 still represent a dilation even though the figure has not been enlarged or reduced? And the answer to that is yes. So we would say all congruent figures are also similar, but not all similar figures are congruent. But if you have two congruent figures, yes, they are considered to be similar with a scale factor of 1. All right, let's look at question 7 in our notes just to make sure we have some of these concepts understood. If a figure is dilated, then the image and the pre-image are said to be similar to one another. So that first blank is similar, not necessarily congruent. They would only be congruent if the scale factor is 1. If point S is dilated to point S prime with a center of dilation J, then the ratio JS prime to JS is constant, meaning not changing. That constant that we're talking about is called the scale factor of the dilation. So when you write the image length over the pre-image length, that gives you your scale factor. The corresponding sides, underlined sides there, of the pre-image and image are said to be proportional to one another. But the corresponding angles, underlined angles there, of the pre-image and image are congruent to one another. So we're not changing the angle measures. It's just the side lengths that are going to be changing potentially. If the scale factor is 1, then the side lengths are not changing either. But any other scale factor, then they are. 1 or negative 1, I should say. So here is some other things we want to make sure we understand. So if your scale factor, and remember these bars around the S is saying absolute value, so it would make a negative scale factor a positive number. So if your scale factor's absolute value is greater than 1, then remember the dilation is creating an enlargement. So if it's greater than 1 or less than negative 1, then its absolute value is greater than 1, and that creates an enlargement, making the figure bigger. If your scale factor is between 0 and 1, or between 0 and negative 1, so that would make its absolute value between 0 and 1, then the dilation is said to be a reduction. It makes a smaller figure. If the scale factor is 1 or negative 1, then its absolute value is 1. That means the image and the pre-image are congruent to one another. Congruent figures can be thought as similar figures with a scale factor of 1 or negative 1. Don't forget, negative 1 also creates congruent figures. If the scale factor is 0, then the image, remember, is a single point, and that point is your center of dilation. And finally, if S is negative, the image is a 180-degree rotation and dilated. And we'll continue on the next video.